Okay, so the previous lesson we learned about the characteristics of a parallelogram, and so what we're moving on to now is proving that a four-sided shape is actually a parallelogram. And so what we have is we have these 5 theorems here. For this to happen, just kind of at the top of your notes, you can just write yourself a little note that both have to happen. So both have to be true. So in theorem 6.8, for it to be proved that it's a parallelogram, I need to prove that both opposite sides are congruent to each other. So if I prove that the top and the bottom, and then the left and the right are equal to each other, that proves that the four-sided shape is a parallelogram. With the next one, the consecutive angles are supplementary. What has to happen here is there has to be a same angle in both of these. And so if I prove that, so if I wanted the same angle to be angle A, so I would have to say that angle A plus angle B is equal to 180. And I would also have to say that angle A plus angle D is also equal to 180. The next one that we have are the opposite angles are congruent to each other. So if I say that B and D are equal to each other, and then also that A and C are equal to each other. Next one down, diagonals being bisected. So again, if you draw your diagonals on there, and then just prove that these pieces are equal and these pieces are equal, just like we did in the previous lesson. If this was my M for my midpoint or whatever, I would have to prove that AM and MC are equal to each other, and DM and MB are equal to each other. And then the last one's a little bit different from anything we've done before. If I prove that opposite sides are congruent, and then those same sides, so that's the key there, is I have to prove that the same sides are equal and parallel. So if I prove that the top and the bottom are equal to each other, and that they're parallel to each other, that proves that the shape is a parallelogram. And obviously, if I prove that both sides are parallel to each other, that would be using definition of a parallelogram, and that's what we'll get into next week. So with these examples, what I want to find x and y, and then once I've done that, then I also want to say the theorem that proves that it's a parallelogram. So for this one right here, I want to prove that opposite sides are equal to each other. So again, these two are equal and these two are equal. So I can write my two equations. 3x minus 5 is equal to 2x plus 1. So I can subtract the 2x over to the other side. Get x minus 5 is equal to 1, so x is equal to 6. Once I find that, I would know that this side over here is going to be 8. And so I would know that y would have to equal 8. So y is, again, my other equation would be y is equal to x plus 2. If I know that x is 6, then I would know that y would have to equal 8. And so again, proving that opposite sides are equal to each other, so that would be theorem 6.8. So I can put theorem 6.8. Same thing, you have to use the theorem number on your Schoology quiz as well, so make sure that we understand that. The next one is I want to prove, let's see, with this one, opposite angles won't be, you could do it with a system of equations, but that's pretty tough. What I can do instead is I can maybe take one of the angles, let's see, take angle H, for example, and prove that it's supplementary to angle E and supplementary to angle G. So I can go y plus 10 plus 3y minus 2 is equal to 180. And then also prove that y plus 10 is, plus angle G, which is 12x plus 7, is equal to 180. So again, combine my like terms, I get 4y plus 8 is equal to 180. So 4y is equal to 172. Do 172 divided by 4, and I get 43. I get y is equal to 43. And then again, I have to do consecutive angles supplementary. So with the other one, I could take that 43 and plug it in for y. So I'll get 43 plus 10 plus 12x, whoopsie, there we go, plus 7 is equal to 180. So combine my like terms together, I think I get 60 when I do that. I get 12x plus 60 is equal to 180. So 12x is equal to 120, so x is equal to 10. And so again, that's using consecutive angles, so that's going to be theorem 6-9. Consecutive angles being supplementary to each other. Flip over to the back. On the back, I'm given lengths that are my diagonals. So again, I know that if I were to name the middle M, I know that BM would be equal to MD. If I prove that AM is equal to MC, I can prove that my diagonals bisect each other. And so when I do that, I'm going to go 3x is equal to 4x minus 5. Again, just be careful whichever way you do this, it doesn't matter. You could subtract the 4x over to the left-hand side to get a negative 1. If you do decide, most of the time we try to use the smaller number to keep our numbers positive. Again, just make sure I keep a 0 on the left-hand side. I have x minus 5. Add the 5 to the other side to get x is equal to 5. And again, that's doing diagonals being bisected, so that's theorem 611. Top right hand side one. This one's a little difficult. Not the math actually, but just to understand what's going on. So what I do have to understand is I've got these angles equal to each other. And so if I remember from when we did proving triangles equal, those are alternate interior angles, which would prove that the top and the bottom are parallel to each other. And so again, whenever I'm saying that, I have to use converse. So I would know that the top and bottom are parallel. I know that CD is parallel to AB. And I know this by converse of, alternate, int, angles theorem. So I know that the top and the bottom are parallel, and so if I prove that the top and the bottom are equal as well, then I can prove that the shape is a parallelogram. So 5x minus 8 is equal to 2x plus 7. So 5x minus 8 is equal to 2x plus 7. Subtract the 2x over to the other side. Get 3x minus 8 is equal to 7. 3x is equal to 15 by adding the 8 to the other side. So x is equal to 5. So I proved that the top and bottom are equal and parallel. So that would be theorem 612, the last one that we have on that page. Okay. Next two down. Same thing, I'm given diagonals. So again, I want to prove that my diagonals are being cut in half by each other. That n is the midpoint. And so I can write 7a minus 6 is equal to 5a plus 2. Again, subtract the 5a to the other side. Get 2a minus 6 is equal to 2. So 2a is equal to 8, and a is equal to 4. Do the same thing with the other diagonals. I can do 2b is equal to b plus 5. Subtract the b over to the other side and get b is equal to 5. That's diagonals bisecting each other, so that's, again, theorem 611. With the next one, again, the easiest way to do this one is to do opposite angles equal to each other. So again, I want to prove that Q and S are equal. I can write my equation as 6y plus 7 is equal to 8y minus 6. Subtract the 6y over to the other side. Get 7 is equal to 2y minus 6. Add the 6 to get 13 is equal to 2y. And I get y is equal to 6.5. I want to take that and plug it back in. So I can plug it back in. If I take the 6.5 and plug it in for this angle right here, I can go 6 times 6.5 plus 7 is equal to 46. So I know that this angle is equal to 46. This angle is equal to 46, which would mean that the other angle, if I did 180 minus 46, that this angle would have to be equal to 134. Angle P would have to be equal to 134. So my other equation, I could go 15x minus 16 is equal to 134. So I get 15x is equal to 150, and so x is equal to 10. Again, that'd be theorem 610. Proving that the shape is a parallelogram because opposite angles are equal to each other. Both opposite angles are equal to each other. Okay. The last one is pretty similar to the one we did in the top right-hand corner. Just by looking at it, I know that the top and the bottom are equal to each other. And then I know that angle A and angle D are supplementary. And so I can, again, if I look at these as, these would be the two parallel lines. This would be my transversal. Angle A and angle D are same side interior angles. So I can say that the top and the bottom, AB, is parallel to CD by converse of same side interior angles theorem. So I know that the top and the bottom are parallel, and they're equal because they're both 5. And so by theorem 612, I know that my shape is a parallelogram.